All right, good afternoon, guys, or good evening, wherever you are. So this is a tutorial hour. We're gonna go through the tutorial sheet for week 8. Um, I assume you have seen it. If you haven't seen it, this is the tutorial sheet for week 8. There are 7 questions. I will start with question number 7 and work backwards. Okay. All right, guys. If you have questions, as usual, please use the chat room, right? And I will answer in as much detail as I can. Right. Okay, guys. So please feel free to ask any questions you guys have. All right. So this is question 7, right? I hope you can read it. If you can't read it, please let me know. I mean, if you can't read it, you should be able to read it from your computer screen, from the PDF file that I just showed you a minute ago, right? So you have an engineering firm that produces components and is assumed to be normally distributed with a standard deviation of 3.4, right? So this is the crucial part of the question, right? Let me see if I can just. Okay. Okay. And you're drawing a sample of size n equal to 9, and that has an average of 100.8. That's the average lifetime is 100.8. And the question is to find the 95% and 98% confidence interval for the mean component lifetime, right? Okay, so let's start with this question 7. I talked about confidence interval this morning, you may recall. The formula that is relevant to this question is this one, because this is the formula that we need to use in order to answer this question, because this is the formula for the population mean when the population variance or the population standard deviation is known. And if you read the question once again, you see that it says explicitly, the question says explicitly that the standard deviation or the population standard deviation is known and it's to be equal to 3.4. Okay. So that's what I'm going to use. So your sigma, so this is the formula I'm going to use. Put this in a box, right? So your sigma is 3.4. That's the population standard deviation. And your n is a sample size, which is 9. And x bar is the average of the sample size of the sample. I mean the sample mean, which is 100.8, right? Okay, and there are 2 parts to this question. The first part is asking you for the 95% confidence interval. So what that means is that 100 times 1 minus alpha is equal to 95, right? So this implies that 1 minus alpha is 0.95, and this implies that alpha is 0.05. All right, so in this formula we need this guy here. So so that's gonna be this, right? And this, if you read this off the table for the normal distribution, which I talked about this morning, right? This will be equal to 1.96, right? Okay, now if you use this formula, if you use this formula, you will get X bar, which is 100.8 plus or minus 1.96 times sigma divided by square root of 9, right? And this, if you work it out, it will be 98.58, 103.02. Okay, so this is the 95% confidence interval for the population mean. The population mean in this case being the lifetime, the mean lifetime. Okay. Right, now part two is asking for the same thing, but this time we are looking for 98%. So your 100 times 1 minus alpha is 98. All right, so which implies that 1 minus alpha is 0.98, and this implies that alpha is 0.02. Right, so this implies that Z, the percentile at 1 minus alpha by 2 is, if you read this off the table, this will be 2.32326, right? All right, so once again, if you use this formula, okay, if you use this formula, you will get 100.8 plus or minus 2.326 times 3.4 divided by square root of 9. Okay, so this will be, if you simplify this, you get 98.16, 103. Okay, so this is the 98% confidence interval, and this is the 95% confidence interval. Is this clear to all of you guys or not? Hello guys, talk to me guys. You sure all of you okay? Yes, no? Okay, okay, good guys, all right. So all right, so we are done with question 7. So the next thing I'm gonna do is, so we're done with this. So the next thing I'm going to do is question 6. So here we are focusing on a chemical concentration in Lake Michigan, and you're told that the standard deviation of that chemical concentration is 0.8 per million, and you're drawing a sample of size 10, and these are the observed concentration levels. And the question is to find the 95% and the 99% confidence interval. So in this case, so this is question 6. In this case, once again, oh, sorry. Hello, my friend. Yeah, this is the previous page. Is it okay? I mean, I will post a copy of the video later today, so you should be able to see it. I mean, within half an hour of the tutorial, you should be able to see the video on the YouTube channel. All right. So once again, for question 6, the formula that you're going to use is this, because you are given, I mean, if you read the question here, it says explicitly that the standard deviation is 0.8. So we are assuming that the population standard deviation sigma is none, right? So this is, so once again, we're going to use this formula, right? So our sigma is 0.8, our n is 10, and x bar is the sample mean, so it's simply the sum of all these values divided by 10. So if you do that using a calculator, this is what you will get. So this is the average of the 10 numbers, right? Now to find the 95% confidence interval, you set 100 times 1 minus alpha equal to 95. Okay, so this implies that 1 minus alpha is 0.95. So this implies that alpha is 0.05. Okay, so this implies that Z, excuse me, this implies that this is equal to 0.975, and this is equal to 1.96. Okay, now if you use this formula, you will get x bar, which is 11.48 plus or minus 1.96, 0.8 divided by the square root of 10. Okay. And now if you work this out, the confidence interval will be this. All right. Are you guys okay with this, guys? Let me know. I mean, if you have any questions, please feel free to use the chat room. All right. All right. For part 2, we are looking for the 99th confidence interval. Okay, 99% confidence interval. So 100 times 1 minus alpha is 99. So your 1 minus alpha is 0.99. All right, so your alpha is 0.01. Yeah, and so your Z 1 minus alpha by 2 will be Z 0.995. Okay, and this, if you read this off the table, you will get this, right? All right, now once again, using the formula that I mentioned earlier, all right, if you use this formula, you will get x bar, which is 11.48 plus or minus 2.576 multiplied by sigma 0.8 divided by the square root of m. This is what you get. Now, if you simplify this, you get 10.83, 12.13. All right, guys. So this is the 99% confidence interval. All right. Any questions on this? This is question 6. Hello, guys. Talk to me. Are you okay with this or no? If not, please feel free to say so. I'm happy to go over again. Okay. All right. So we are done with question 6. Question 5 and question 6 and question 7. The next I'm going to look at is question 5. So here you have a random sample from a geometric distribution with unknown parameter p. The question is to write down the likelihood and find the maximum likelihood estimator. I mean, I think I did this question earlier, but I would do it again if you'd like me to. So this is so the first part is to write down the likelihood function. Okay, so remember the likelihood is the product of the density function. In this case, it's the probability mass function because you're dealing with the geometric the geometric distribution has this as the PMF, right? Now this, I'm going to do it slowly. So yeah, now the product of P is a constant, so if you take the product 1 to n, it becomes this, right? And the product of this is yeah. So this is P to the power n, 1 minus P. Now if you take the summation inside the brackets, right, you will get sum of xi, right, and minus the sum of 1, which is sum of 1 is n. Okay, so this is what you get. So this is the likelihood function. The second step, I'm sure you guys remember, the second step of maximum likelihood estimation is to take the log of the likelihood. So you take the log of L of P. So this becomes n log of P plus okay. All right, and the third step of maximum likelihood is to take the derivative. Is to take the derivative with respect to P. All right, so if you take the derivative with respect to P, you get n over P. Right, that's the derivative of this, and the derivative of this is yes. Okay, guys. Now we need to solve this equation that put this equal to 0 and solve this equation for P, right? So you get n over P equal to okay. Right, now cross multiplying, you get n times 1 minus P, which is this, and then you have P times this gives you okay. Now these two guys cancel out, so your solution for P, let me call it P hat, right? It's gonna be n divided by the sum of xi, which is 1 divided by x bar. X bar is the sample mean. Now the final step of maximum likelihood estimation is to show that the second order derivative is negative. So I'm going to take the second order derivative, which is the first order derivative of this, right? So it's going to be minus Okay. Okay, and this is clearly less than 0 because number one, this is a negative number. Number two, the term in the denominator is non-negative because remember xi being a geometric variable has to be greater than or equal to 1 for every I, okay, by definition of geometric distribution, which implies that the sum of xi, right, has to be greater than or equal to the sum of 1. Okay, now sum of 1, I from 1 to n is n, right? So okay, all right, so therefore the numerator, that is the sum of xi minus n, has to be non-negative. So that means that the whole thing has to be less than 0. So hence we have shown, so hence, just to let me excuse it in here, hence we have shown that p hat equal to 1 divided by x bar is the MLE of p. All right, guys, so this completes question 5. Okay, are you okay with this? Hello, guys. Please let me know. Are you guys okay or not okay? Okay, thank you. All right, the next question I'm going to look at, is question 4. So is, I don't know if you can, the sun is shining here, so it's really difficult to see. Question 4 is, question 4 is this one here. This is question 4. If you can't see this clearly, please look at your the PDF file on the website. You may be able to see it better. Okay. So basically, the question says that you have 5 data points coming from a binomial distribution with parameters 3 and p. The first part is asking you to write down the likelihood function for p, right? So that's what I'm going to do. So this is question number 4, part 1, right? So the likelihood is a product I from 1 to 5 of the density, or in this case the probability mass function of the binomial distribution with parameters 3 and p. Okay, so this is the, now I'm going to show you how to simplify this, right? There are 3 terms here. So all right, this is the first term. This is the second term, right? This is the third term, right? All right, so you get Yeah, you get this. Now the product of this term is gonna be P power the sum of xi, I from 1 to 5. And the product of this term is gonna be 1 minus P power the sum of 3 minus xi. Okay. So this will become now. If you simplify this, you should take the sum inside the brackets, right? You will get 1 minus P power the sum of 3 is 15 minus the sum of xi. Okay, guys. Is this okay with all of you so far? Right. If you have questions, please let me know. Right. Right. The next part. So that's the first part of question 4. The second part of question 4. In the second part, you are actually given the values for the x's. You are told that x1 is equal to 1, x2 is equal to 3, x3 is equal to 2, x4 is equal to 2, and x5 is equal to 3. So these are the data values that you are given. Now, if you sum all these numbers, so you should sum these values, that is sum of xi from I from 1 to 5, you will get this to be 11, all right? All right, so this guy here is gonna be equal to L of P, 3 choose 1, 3 choose 3, 3 choose 2, 3 choose 2, 3 choose 3, multiplied by P power 11, 1 minus P power 15 minus 11. All right. Okay, now if you simplify this, guys, you get 27 P to the power 11, 1 minus P to the power 4. Okay. All right, guys. Now, in order to find the maximum likelihood estimator, if you read the question, it suggests that you create a table, right, with 4 different values for P, 0.5, 0.6, 0.7, and 0.8, right? Okay, now for each of these values of P, I'm going to work out this. Obviously, I need a calculator, so I have already done it. So for when P is 0.5, this guy here turns out to be 8.24 times 10 to the power minus 4, right? When P is 0.6, you get this, right? And when P is 0.7, you get and when P is 0.8, you get okay. Now, remember, the maximum likelihood estimator is the one for which the likelihood value is the largest. Now, which one is the largest here, guys? Tell me. Of these, the largest is clearly this one, right? This one is the largest, right? Okay, so the MLE, so MLE of P is 0.7. Okay. All right, guys. So this completes question 4. Are you okay with that or not? Everybody okay with question 4? Or you want me to explain things? If you want me to explain, I'm happy to do that. Okay. All right. So okay, we're done with question 4. All right, the next question, the next one I'm going to do is question 3. So here you are given a random sample from this PDF. The first part is to show that X bar is a biased estimator of delta. Okay, let's see how we can do that. So this is question 3. So you have this density, which is Fx equal to E minus X plus delta, where X is greater than delta. Now we want to find the bias of X bar as an estimator of delta, right? Now remember I did about 20 questions on this a while ago. The bias is defined as the expectation of the estimator minus the parameter that you're trying to estimate, right? So this is the expectation of X bar minus delta, right? Okay, guys, so let's see how we can do this. All right. Now take the expectation inside, you get 1 over n times the sum of the expectation of xi minus delta, right? Now to find the expectation, you just need to integrate the density, right? So this becomes 1 over n times the sum of integral from delta to infinity of x okay, like this, yeah. Now delta is a constant, so you can pull it outside. So this becomes E of delta divided by n yeah. All right, now any ideas on how you can do the integration? I'm sure you guys know integration better than I do. To do this integration, yes, exactly. You can do it by parts. So if you use integration by parts, this is what you will get. All right, you get x minus is plus. Right, this is what you will get. Yeah. All right, now the limit, sorry, this should be infinity, guys. Sorry, excuse me. I don't know what I'm thinking. This is infinity. The limit at infinity is 0, and the limit at delta is minus delta this. And then the integral of this is not difficult, so this is minus okay, minus delta, right? So this becomes delta, sorry, E minus delta, and the limit at infinity is 0, and then you have plus E minus delta, like this, okay? Right now, you can multiply across by this term, so you get 1 over n times the sum 1 to n of delta plus 1 minus delta, right? So this is going to be okay. This is this. Now the n and the n cancel, so this becomes delta plus 1 minus delta, which is equal to 1 and which is not equal to 0. So the bias. So what we have shown, guys, is that the bias is not equal to 0. So in other words, we have shown that X bar is a biased estimator. It's a biased estimator of delta, right? Are you guys okay with this or no? Yeah. Did you? Hello, guys. If you're not okay, how did you get rid of the exponential? Okay, that's because, guys, because there is this term here, right? This term here, and there is these two terms here. So when you multiply this, when you take this inside and multiply, you get these two cancel each other, and these two cancel each other too. So you get delta plus 1. Yeah. All right, guys. So that's the first part of question number 3. Now, any other questions before I do the second part? Hello, guys. Talk to me. Are you guys okay so far? So the second part of part 2, this is part 2 of, so what we have shown so far that the bias of the estimator, right, is equal to 1, right? 1 is a constant, of course, which implies that the limit, because the second part is asking you for the limit of the bias as n approaches infinity, right? That will also be 1, because remember, 1 is a constant with respect to n, so the limit of a constant is itself, right? All right, so the limit of the bias is equal to 1, right? All right, now part 3 is asking you, if you read the question here, part 3 of question 3 is asking you, I don't know whether you can read this. If you can't read this, please look at your laptop. It's asking you to propose an alternative unbiased estimator of delta. So the new estimator that you can propose, remember, you should look at part 1. You should look at part 1. What we have shown is that the bias of X bar, the bias of X bar is delta plus 1, right? So in order to, sorry, the bias of X bar is 1, right? So in order to make this equal to 0, what you have to do is to subtract 1 from the estimator. So if you take away 1 from the estimator, the bias will become 0. You follow what I'm saying? Okay. All right. So that's what I'm going to do. I'm going to define the new estimator as I'm going to define the new estimator as x bar take away 1. Okay. So the bias of the new estimator is going to be this, yeah. And this is going to be the expectation of x bar minus 1 minus delta. Now we know from part 1, that the expectation of x bar is delta plus 1, and this is 0, right? So we have shown, hence we have shown that delta hat, the new estimator, right, is unbiased for delta. All right, guys, is that clear to us? So this completes question number 3. Are you okay with this or no? Talk to me, guys, please. Everybody okay with question 3? Yeah. All right. So let me do the next question. So I've done. Okay. The next question is question 2. You have, again, it's difficult to read because the sun is focusing here right now, right here. But you can read this better in your own laptop. So please look at the PDF file that on the course website. So you have x bar 1 and x bar 2. They are the sample means of 2 independent random samples of size n1 and n2, respectively, from a normal with parameters mu and sigma squared. Now you have this new estimator, which is this one, all right? And the question is to show that the bias is 0 and also to find the variance, right? So let's see how we can do this, okay? So I'm going to do the first part. The first part is to show that the bias is 0. So this is question 2. Now remember, x bar 1 is the sample mean of a sample of size n1 from normal, right? So from what we learned earlier, x bar 1 must have this distribution with parameters. This is the mean parameter and this is the variance parameter. This is a result I mentioned to you in the video on normal distribution. If you don't remember, please have a look again, right? And this okay, all right. Okay, so in order to find, so we have this new estimator, which is mu hat equal to ax bar 1 plus 1 minus ax bar 2. So we are asked to show that this is an unbiased estimator. So what we need to find is the bias. We need to find the bias of mu hat, which is as you know, is the expectation of mu hat minus mu, right? Which is the expectation of yeah. Now if you take the expectation inside, yeah, this will become 8 times the expectation of x bar 1 plus 1 minus 8 times the expectation of x bar 2. Okay. All right. Now from this statement here, right, you can see immediately that the expectation of x bar 1 must be mu, right? So this is A times mu plus 1 minus A times. From this statement, you can see that the expectation of x bar 2 must be mu 2, right? And this is clearly equal to 0, right? So hence, what we have shown that mu hat is unbiased for mu. Right? Is this clear to you or no? So this is the first part of question number 2. Hello guys, talk to me guys, please. Are you okay so far? Yeah, thank you. All right, the second part of question 2 is to find the variance. To find the variance of, so I'm working on question 2 still. To find the variance of mu hat, this is going to be the variance of A x bar 1 plus 1 minus A times x bar 2, right? If you take the variance inside, A is a constant, so it will become A squared times the variance of x bar 1 plus 1 minus A squared times the variance of x bar 2, right? Okay, guys. Now we know from what I mentioned a second ago that the variance of x bar 1, is sigma squared divided by n1, right? And the variance of x bar 2 is sigma squared divided by n2, right? Okay. So what you have is the following. You have a squared divided by n1 plus 1 minus a squared divided by n2, everything multiplied by sigma squared, right? Okay, now the question is, you should return to the question. It's asking you to find the value for A. I don't know if you can read this clearly, but if you look at your laptop, you'll be able to see better. That is to find the value for A for which the variance is the minimum, right? Now, if you look over here, the only thing that depends on A is this, right? So let's call this G of A, right? Now we need to find the minimum of this function G as a function of A. Now, I'm sure you've done calculus more than I have. Now, in order to find the minimum of a function, what you need to do is to differentiate and set it equal to 0 and so on. All right. Okay. So what I'm going to do first is I'm going to take the derivative with respect to A. So it will become 2A divided by n1 minus 2 times 1 minus A divided by n2, right? And if you set this to 0 and solve for A, right, you will get, I don't have the time, but I will just, if you solve this equation for A, this is what you will get as the solution. Now the second order derivative, right, which is the first order derivative of this, is 2 divided by n1 plus 2 divided by n2, which is a positive number, right? Since the second order derivative is negative, G of A is minimized when or at A equal to n1 divided by n1 plus n2, right? So in other words, what I'm saying is that because the variance is G of A times sigma squared, what I'm saying is the following, that is the variance of mu hat is minimized, all right, at A equal to N1 divided by N1 plus N2. All right, so this completes question number 2. I don't have the time to do question 1, but question 1 is pretty trivial. You shouldn't have difficulties to do question 1. Anyway, I will post the solutions to all the 8 questions in the website on Thursday of this week. So you should be able to see the full solutions, the handwritten solution, as well as the video solutions for all, as well as the typed solutions. There are 3 different forms of solutions for all 8 questions on Thursday of this week. All right, guys. So any questions on what I have done today, please let me know. Are you guys okay? Hello, guys. You've been quiet today. What's up? All right. Thank you. All right. Have a great evening wherever you are. And any questions you have on my course, please feel free to contact me 24/7 by email, Skype, Zoom, or phone. My phone number, I'm sure all of you know, is 0161-273-2941. Right? So take care of yourself wherever you are. Bye.